Hi, I'm Bill Ritchie, and I'm about to show you on this video viscosity printing from 1977, and transferred it from this old video cassette tape. But before I start, I thought I should say a few words. You're going to hear some loud noises. You're going to see kind of a mixture of things that might make you wonder. I want you to know that outside the University of Washington printmaking studio, at the time there was a row of holly trees, and they chose that day to come and cut them down. So you're going to be hearing their chainsaws going in the background, and it may make you wonder why we didn't tell them to shut up and why we don't seem to even notice it. But that's just how it was at the time. The video is what they call video verité. It's recorded live with very little editing, and pretty much the way it happened. And I thought I'd just preserve it in that way, and hope you enjoy it. I might mention too that it was the first time the University of Washington had a color camera that they could take out of the studio, and it was the first time they had a color recording machine, the famous open reel Sony 5850, I think it was. And so the production quality isn't quite what we would expect today, but I think you'll get the point and learn how you could do viscosity printing.
Hello, my name is Bill Ritchie, and today I'm going to demonstrate viscosity printing. I learned the process myself from Anne Breivik in Oslo, and she learned it in turn from Stanley Hayter in Paris. Viscosity printing has the advantage for people who want to print many colors at one time on the plate. It's a color separation process whereby you can lay as many as 3 colors at one time on a printing plate. In fact, 4 colors if you have a plate that's inked in tallow. For the demonstration, I'm going to use 2 colors. The first thing that I want to show is the plate itself. Point out, although I don't know if you can see, perhaps if we get a close-up shot on this, you can see the relief in this plate. This is a collograph plate. I made it very quickly using spray mint and mat board. 2-ply mat board and a base of 4-ply mat board. So we have a level difference here. It's not one flat surface. There's a definite buildup of the surface. I'd say it's about a 32nd of an inch thick here. Now it doesn't take such a very deep dimensional change to get an effect with viscosity printing. Another example I have is an etching plate, and you can't see the change here, but the depth here is probably about 1/64 of an inch, etched very deeply. Now some of the ink will sit up high on the plate, these are the higher parts, and others of the ink will go down below. Another plate to have in the studio might be a little bit easier to see the relief. That's the first prerequisite for viscosity printing, is that you have a plate of at least 2 different levels, either etched or built up. The second thing you need for viscosity printing are rollers, and there are 2 considerations with the roller: the durometer and the diameter. The durometer has to do with the hardness. Now these rollers we keep here at the studio at the UW have a durometer reading of about 25 and 45. The word durometer comes from the little instrument that's used to measure their hardness. I don't have one, unfortunately, to show you. But what it does is it pokes any materials, even the flesh on your arm, and will give you a reading. And the softer it is, the lower the reading will be. So a roller of 10 durometers would be extremely soft. I suppose my arm right now, since I'm kind of out of condition, is probably about 6 durometers. This roller is 25, and the other roller is more like 40. Now if you had 3 rollers, you'd have to select them for 3 hardnesses. So you might have a 15 durometer, a 30 durometer, and a 50 durometer. And then your plates, if they had 3 different levels, would read those colors from those 3 different rollers accordingly to how far down into the plate these rollers would sink, in effect. The second consideration is the diameter. These rollers are typical lithography rollers, and so their diameter is 4.5 inches. The reason diameter is important is that the greater your diameter, then the larger plate you can print. Isn't it diameter times pi? 3.14 times the diameter gives you the circumference, which is in effect the length of an ink run that you can make. So these run approximately 13 inches. If you had plates that were 14 inches, you'd be in trouble in one dimension. Their length this roller is a 16-inch roller, and the other one is about 17. So we have a dimensional limitation here of the length of the roller and the length at which it will run. So some studios will equip themselves with, people in studios will equip themselves with large rollers, some 10, 12, 15-inch diameter rollers, ranging anywhere from 15 inches long to even 40 inches long. Those rollers, of course, are not very common, but a shop that does a lot of viscosity printing will have a selection of rollers considered when they purchase them for their durometer and their diameter. So those 2 things have to be considered. I don't want to give the impression that you can't do viscosity unless you have these big rollers. It's just that if you have little speedball rollers or little 4-inch, 1-inch diameter rollers, you're limited to a plate 3 by 4 inches. It can be done. But those are the rollers. The next thing you consider is the inks. And we've mixed up some colors here for the demonstration. And I'm going to show how they have to be modified and tested for their separation. Now here's where the word viscosity comes in. The viscosity of an ink refers to how thick or thin or how runny or stiff that ink is. All 4 of these inks are of a viscosity just as you'd find them in the can. These happen to be Liber inks. They're offset news printing inks, and this is about how thick they are. You can judge them by the way they drop off the end of the knife. This ink has a lot of white in it, and white is usually a little stiffer as it comes from the can, so it has a higher viscosity. Low viscosity means very runny. high viscosity means very stiff. Now, as they come from the can, viscosity printing probably wouldn't work. Their viscosity is so similar that the inks would simply lay right over the top of each other, and we want them to separate. So we have to modify them. And for this process, the modifiers I recommend are linseed oil and magnesium carbonate. Magnesium carbonate, when you add it to the ink and mix it in, will stiffen it. In other words, it'll increase the viscosity. It has a peculiar property also, even though it looks like a white powder that might make the ink look white, it doesn't at all. It disappears, completely disappears into the ink, and doesn't affect the color fastness of the ink. It doesn't cause any deterioration in the paper. So it's an ideal material to mix with ink, and it's a standard modifier in most print shops, magnesium carbonate. We call it mag around shops. The other modifier is linseed oil. Now I recommend that when you use linseed oil for a modifier, that you choose a kind that's made for artists' use, such as for oil painting. This happens to be a type that's sold in art supply stores. You can use, of course, cheap, low-grade linseed oils, but their acid content is so high that you'd be risking shortening the life of your work, because the acids would tend to deteriorate both the paper and the value of the pigment. Okay, now presumably you would have made some choices, or you'd have some idea as to which color you want where on the plate, and as this demonstration goes along, I think you'll see the sense of that. I'm just going to arbitrarily stiffen this light green color, and you can see you add quite a lot of magnesium carbonate. I should warn you that when you mix magnesium carbonate into an ink, the powder tends to fly around. It's very light, and if you're not careful, you'll have it all over the studio. So mix slowly at first until you get most of it worked in. For a quantity of ink like this, it takes at least a teaspoon to make a noticeable difference in the viscosity. At first it will seem very stiff, almost dry, but as you keep working it, it'll go back to a more, what shall I say, ink-like consistency. Now you can see how much stiffer it is now. It barely falls off the end of the ink knife. That was probably about a tablespoon of mag. Now sometimes, if you make one of your inks very stiff, you don't have to modify the other one. There's enough difference in their viscosity to cause them to separate during the inking stage. But just for the sake of this demonstration, I'm going to add a little linseed oil to the other color. in just a second here. I'll be sure that mag powder is worked in, there are no lumps left. Okay. It doesn't take much oil. This ink is already very low in viscosity. I'm getting a little bit of mag powder in there, but those few little crumbs won't matter. If you want to ensure a very good separation, then you make that difference in viscosity very great. Now, a person who decides to take up viscosity printing as a specialty, or because of certain work they are doing requires a lot of craft, a lot of skill in the application of this craft, you can develop a very interesting range of control by paying close attention to the viscosities and how they roll out. Quantity will make a difference too, as I'll show you a little later in this demonstration. Okay, the next step is to do a little test. Now, to make this effective, I'm going to have to hold up my ink slab so that we can get a good view of how this happens. First, you take two small brayers. I keep these 1-inch brayers for just this purpose, testing inks, and you roll them out. Now, I'm making 3 bands here because I have 3 different quantities and I can adjust the quantity of ink just the way I like it. That's the low viscosity. We'll set that there till it's ready. And then the high viscosity. There we have them. Now on the slab, could I get you to come over and help me hold this slab at an angle like that? Can you handle that? Yeah. Okay. Now here's where a very important rule comes in. And it's been debated which would go first, the high viscosity or the low viscosity. And I always say the low viscosity goes first. The low viscosity ink goes first. And this will be true also when we ink up the plate. Now this is how you do a test. You roll out a layer of ink, and when you pass the second roller across, they should separate. Does that show on the... It does. Okay. The first time I saw that demonstrated, my friend and teacher Anne Breivik did it with black and white ink. Thank you, that's now. And I never forget the feeling when I saw that white ink go across the black and completely ignore, so to speak, that black band. I've never seen 2 inks separate quite that way. Now you'll notice at this point that the high viscosity ink has picked up some of the low viscosity ink. Now this is just one of the drawbacks of the process. You'll have to clean this roller. If that test had failed, you'd have to clean this roller before you tried the test again. Also, before you tried the test again, you obviously have to work on the viscosities of your inks once more. But this ink stays clean, so you never have to clean the roller that lays down the low viscosity ink, just the high viscosity ink. And obviously you'd want to be sure that you'd have mixed up enough color before you started the whole process so that you wouldn't run out and have to stop and mix your colors again. Okay, the inks are mixed and tested and they all work, so you're ready to roll them out. That cardinal rule I mentioned a minute ago about your low viscosity ink going first, you have to remember now in connection with the use of the rollers. One roller as I said, is very hard. That's this roller on this side. The other one is softer. So if you're making notes, note that the low viscosity ink goes on the hard roller, and it will ride on the high places. You probably have your own methods for remembering that, but I remember it because hard and high both start with H. The low viscosity ink goes on the hard roller and rides on the high places. Again, the debate I mentioned a second ago was, people say, well, wouldn't it work just the same if you reversed? And I always say, go ahead and try it. And my memory serves me correctly, it's never worked the same. Rolling the ink. Now, most people into printmaking have had experience rolling out ink. You know that you have to give the roller a little turn each time, that you have to roll 90 degrees to get that ink layer even. Also, if you have any kind of an ink slab that isn't truly flat, you'll have a little bit of a problem. Now, it's my suggestion that you start out with too much ink, roll it out, and then scrape back and get rid of your excess. It makes it a little easier. And at first you won't know just exactly how much ink to use, but you catch on pretty quickly. The more ink you use, the better the separation will be, because you have a lot more oil. With the greater amount of ink, you have more oil, and that's what's causing the separation to occur. Okay, that does it for the low viscosity ink. Do the same with the high viscosity ink. This one won't be quite as easy to roll out as the low viscosity was. In fact, you do quite a lot of it just with the ink knife when you start. It makes it a lot easier. Now the two are ready to go. If the quantity that I have on the slab is the same as it was in the tests, and I think it is, then we should have success with our separation. First, I'm going to try this method on the little collograph plate that I made. Notice on the slab here that I have what are called runners, strips of mat board, 4-ply mat board, just taped down to the marble slab, or it could be a glass slab, with masking tape. These are called runners, and they prevent the roller from having to push up and ride over the edge of the plate, because you want the plate to receive a very smooth layer. The runners will help ensure that. So first I'll go get my hard roller with the low viscosity, and at this stage I can ink as many times as I like because the plate is clean. No pressure here, and because it's a new plate, I might mention too, it will tend to absorb some of the oils, so I'm going to be certain that I have given it a good generous quantity so that my viscosity isn't thrown off by that new plate. You wouldn't have to worry about that on a plate that's been used before. It has been, this paper plate has been sealed, but you can't rely on the sealer to prevent absorption. Notice too that I don't ink the plate more than one time with each charging of the roller. This is called charging the roller with ink. If you inked it several times without charging, you'd be transferring its own design back onto the plate, and you'd have a hard time getting the colors to lay smoothly. If your roller skids on the plate, you'll have to re-ink it, because skid marks will be translated when you lay down the other color. You'll see the skid marks, so the color has to be smooth. This roller weighs about 12 pounds, so it's not necessary to push down on it. But this roller is quite light, although it only weighs about 3 pounds. So when I ink with this roller, in order to get the lower areas, these areas that haven't had any ink on them, in order to make this soft roller sink down, I have to use some pressure. I'm going to change the position here just a little, make it a little easier on me. And I only get one time with this. Now you see what's happened. The blue ink is untouched. Actually, it gave up half of its color, and that's now on the roller. That means that before you use this roller again, you'd have to be cleaning it off. In Hayter's workshop in Paris, who I visited in '69, when people were doing viscosity printing, they had a team of about 8 people, and somebody's job was simply clean that roller over and over again. That's all he did, was clean the roller, make it ready for the next pass. Also, when I was inking the roller the first time, I was leaning on it, I was putting a little pressure on it, and so it touched right up here in this corner. Now maybe the paper's warped a little bit. If that was a problem for you, you'd simply have to work out a way to avoid that happening, maybe with stencils or that sort of thing. So this plate is ready to print. I'll ink another plate before I go into the printing stage. this time a metal plate. Because that metal plate has a very slight warp to it, I may have to lean on the roller just a little bit to force the plate into being flat. But remember, when you're laying down the low viscosity ink with the hard roller, you have a number of times to make it correct. Now, before I can ink that, I'll have to clean this roller. There's a lot of ink on this roller, and you can speed up the process a bit by blotting some of it off with paper. Now, most rollers can only be cleaned with the right solvents. You have to be careful not to use a solvent that's too strong, might dissolve the roller itself. Kerosene is used quite a lot, and naphtha. Some people have used white gasoline. I'll be using kerosene for this. Start with a fairly well-soaked rag. This is when it's good to have a friend working with you. Well, it's a good way to lose a friend, too. Fortunately, you don't have to clean the roller to the same extent that you would if you were finished for the day and putting it away. Then, of course, the roller has to be totally cleaned of any ink. Now it's just important to get all the dark color off that I have here, and any residue of kerosene, of course, has to be cleaned off. Now I've lost some of the ink that I had originally, so I'll have to replenish the slab. This is why you have to be sure you've mixed up enough color in advance. I think this partly explains, too, why so many of the prints that come out of the Hayter studio in Paris are based on the same palette. Because several people would be sharing the same colors, literally using the same slabs. That's the inking process. Now all we have to do is print them. When you print a plate in a roller press like this, that it's a good idea to load the press and the blankets beforehand, and that way keep the paper from touching the plate. The normal procedure is just to lay the plate in the press and then put the paper on top of it. But if the paper touches the ink, which is just sitting on the surface, you'll get what's called push. Push is caused when the paper actually rubs across the surface of the ink. So if it's possible, if your paper is large enough to allow this, I would recommend this method of loading the press first, then putting the paper back over the top of the roller this way before you print. Maybe you could put the press through for me simply. Turn it for me. A big press and big piece of paper, it takes sometimes two people to keep that paper from falling over. Great, thank you. I'm reminded when I was in Oslo working with Anne Breivik, I did my first viscosity print. I used gray and green, I think it was. And she said where she studied, you always mixed colors and primaries or complements. And in this example, we've used two values of, well, we used a green and a blue, so I guess it's just something to do with Seattle. I couldn't explain it to Anne at the time. Well, that's the process. you have any questions? You people who are actually here in 1977. Cleaning up these ink slabs and rollers can be a very time-consuming and wasteful job. I've devised a way to make that much less of a problem. And I'll give these steps right now. Scrape the slab first with a good smooth scraper, putty knife, ink knife, whatever you call it. So you've scraped up the bulk of this ink. Then sprinkle a little kerosene. Doesn't take much. Sprinkle that kerosene on the slab and then work it around so that all the remaining ink is covered just a little bit with some kerosene. You should only use kerosene or naphtha cleaning up this way. Don't use any strong solvents such as our Varn 120 or Eldorado cleaner, lacquer thinner, alcohol. None of those solvents should be used for cleaning up. Only kerosene or naphtha. White gas has been mentioned as a good cleaning agent, but it's also extremely flammable and dangerous to use. Now that you've worked the kerosene around with the ink knife, pick up your roller and work it into this kerosene. And spin it around so that the ink coating on the roller is well covered with kerosene. Then rack your roller, put down a sheet of newspaper. In fact, I would suggest 2 or 3 full pages of newspaper. Lay it right down on the kerosene and roll that out. Right away you are a long way to being finished cleaning. Right away you've lost a lot of that ink that was on there. Now if you get both sides of the sheet this way and grip it, you can begin wiping up the slab. Tuck it under. You keep tucking your newspaper under until it's a tight little ball, and you will have picked up practically all of the ink and kerosene. From the slab. Then cleaning the roller, again using kerosene only and a little cotton rag. Put a little kerosene on the cloth and begin this wiping process. Now, to get a roller truly clean, and anytime you're in a, let's say, a community shop where people are sharing equipment, sharing rollers, this is very important. If you don't clean rollers thoroughly after every day's use, they will eventually become glazed, and then their surface won't perform the way they were designed to. It sometimes takes 10 to 20 minutes to do a complete job of cleaning a roller. And I find this method is the best. And when that rag is very saturated with ink residue and kerosene, you can use a second rag. I'm going to do this just quickly for the purposes of the demonstration. There's one last step that you have to do. As long as you're getting a color from the roller, it isn't clean. Now sometimes a black rubber roller, a occasionally some of the plastic rollers will leave their own residue, black for example, coming from rubber. If you've used green ink and you're getting a black residue, you're probably just wiping the surface of rubber off. So of course it's futile to go on any further. The last thing is to clean up the residue of kerosene. Kerosene is very greasy, and it would interfere with your inks. The next time inks were laid out on this greasy residue, you'd have some problems. So you should use then a very strong solvent such as Varn 120 or El Dorado cleaner to finish getting rid of that last residue of greasy kerosene. Little brayers are cleaned the same way. A spot of just a little kerosene. Roll those out on newspaper. And then finish with the cloth. Ink knives. Work those around in that kerosene residue. And then wipe them off. The plate itself. Let's see, Nick, could you hand me that zinc plate, please? The plate itself should be cleaned first with kerosene. To get most of the ink off, just use your kerosene. And then finish with Varn.